Hello students. I hope you all are feeling charged up because we are going to dive into Unit 1, Introduction to Machine Learning. And trust me, this unit is going to be one of the most exciting ones in your syllabus. Machine learning is not just a buzzword. It is a powerful concept that is already shaping our lives every day. These are the most expected, important, and previous year questions. So listen carefully and understand each concept deeply. Let's begin. Let's start with the first question. What is machine learning? Explain applications of machine learning in data science. Machine learning is a type of artificial intelligence where computers learn from data and make decisions without being explicitly programmed for every task. Think of it like teaching a child to recognize fruits. Once the child sees enough apples and bananas, they start recognizing them on their own. Similarly, a machine learns patterns from data and applies them in real scenarios. In data science, machine learning is used to predict customer behavior, detect fraud, recommend movies, recognize faces, translate languages, and much more. It makes the data intelligent and turns raw information into smart decisions. Now let's move on to our next important topic, machine learning model working. From this topic, we can expect questions like, how machine learning model works? Explain various steps involved. The working of a machine learning model involves several steps. First, we collect data which serves as the input. Then, we preprocess the data to clean it and convert it into a usable format. After that, we select a suitable algorithm based on the type of problem. Then comes training the model using the data so that it can learn patterns. After training, we test the model with new data to evaluate its accuracy. Finally, we deploy the model for real-world use, where it can keep learning and improving. Now let's move on to our next important topic, steps in developing a machine learning application. From this topic, we can expect questions like, describe the various steps involved in developing a machine learning application. Developing a machine learning application involves identifying the problem you want to solve. After that, you collect and prepare the data. The next step is choosing the right algorithm depending on whether it is classification, regression, clustering, or recommendation. Then, you train the model using training data and test its accuracy using testing data. If the accuracy is not satisfactory, you may go back and tune the model or improve the data quality. Finally, once satisfied, you deploy the model into production so users can benefit from it. Now let's move on to our next important topic, machine learning versus traditional programming. From this topic, we can expect questions like, compare machine learning with traditional programming. Discuss types of machine learning with suitable examples. In traditional programming, a developer writes step-by-step instructions that the computer follows. But in machine learning, the computer learns the rules from data. For example, in traditional programming, you write exact logic to detect spam emails. In machine learning, you train the model using thousands of emails, and it learns which ones are spam. The types of machine learning include supervised learning where the model is trained using labeled data, unsupervised learning where the model finds patterns in unlabeled data, and reinforcement learning where the model learns by trial and error based on rewards and punishments. Now let's move on to our next important topic, artificial intelligence versus machine learning. From this topic, we can expect questions like, compare artificial intelligence and machine learning. Artificial intelligence is the broader concept of machines being able to carry out tasks in a way that we consider smart. Machine learning is a subset of artificial intelligence where we teach machines to learn from data. Artificial intelligence includes everything from logical reasoning, natural language processing, robotics, and even machine learning. Machine learning, on the other hand, focuses mainly on pattern recognition and prediction using data. Now let's move on to our next important topic, supervised and unsupervised learning. From this topic, we can expect questions like, explain supervised unsupervised and semi-supervised learning. Supervised learning is when the model is trained on labeled data, meaning the input and output are both provided. For example, training a model to identify cats and dogs by giving it thousands of labeled images. Unsupervised learning is when only input data is given, and the model has to find hidden patterns, like grouping similar customers based on behavior. Semi-supervised learning is a mix of both, where a small portion of data is labeled and the rest is unlabeled, helping the model learn better when labeled data is scarce. Now let's move on to our next important topic, supervised versus reinforcement learning. From this topic, we can expect questions like, what are the main differences between supervised learning and reinforcement learning? Supervised learning is based on historical data, where the correct answers are already known. The model learns from these examples and applies it to new data. Reinforcement learning, however, works by interacting with the environment and learning from feedback in the form of rewards or penalties. For example, a chess-playing AI uses reinforcement learning to improve by winning or losing games, while supervised learning would need past game data to learn. Now let's move on to our next important topic, advantages and limitations of supervised learning. From this topic, we can expect questions like, explain the key advantages and limitations of supervised learning. Supervised learning is powerful because it gives accurate results when the data is labeled properly. It is easy to understand and use for tasks like classification and regression. But its limitation is that it needs a large amount of labeled data, which can be expensive and time-consuming to collect. Also, it may not work well if the data changes over time, or if new patterns emerge. Now let's move on to our next important topic, geometric models. From this topic, we can expect questions like, explain geometric models and its types. Geometric models in machine learning represent data points in a geometric space. Each point is like a feature vector in a multi-dimensional space. These models focus on the distance, direction, and boundaries between data points. Some types of geometric models include nearest neighbor models, where a data point is classified based on the closest existing points, and linear models, where data is separated by straight lines or hyperplanes. Now let's move on to our next important topic, geometric model versus probabilistic model. From this topic, we can expect questions like, explain geometric model and probabilistic model with suitable examples. Geometric models rely on the shape and position of data in space. They classify or predict based on spatial closeness. Probabilistic models, on the other hand, rely on the probability that a data point belongs to a particular class. For example, in spam detection, a geometric model may look at the pattern of words, while a probabilistic model may calculate the likelihood of the email being spam based on word frequency. Now let's move on to our next important topic, logical models. From this topic, we can expect questions like, what are logical models in machine learning? Explain with examples. Logical models use logic-based rules to make decisions. These models use conditions like if-then statements. For example, a rule-based system that says, if the temperature is above 30 degrees and the humidity is high, then switch on the fan. These models are very useful when the decision-making process can be expressed clearly using logic. Now let's move on to our next important topic, grouping and grading models. From this topic, we can expect questions like, describe grouping and grading models. Grouping models cluster data into groups based on similarities. For example, a company may group customers based on their buying behavior. Grading models assign a score or label, such as grading an email as low, medium, or high priority. Both models are useful in categorizing and ranking data effectively. Now let's move on to our next important topic, parametric and non-parametric models. From this topic, we can expect questions like, describe parametric and non-parametric machine learning models. Parametric models make assumptions about the structure of data. They are defined by a set number of parameters. For example, linear regression is a parametric model. Non-parametric models do not assume any fixed form and can grow in complexity with the data. Decision trees and nearest neighbor methods are examples of non-parametric models. Now let's move on to our next important topic, data formats in machine learning. From this topic, we can expect questions like, explain different data formats used in machine learning. In machine learning, data can come in various formats like structured data in tables, unstructured data like text and images, and semi-structured data like JSON and XML files. The choice of data format affects the preprocessing steps and the model selection. Now let's move on to our next important topic, data formats for machine learning elements. From this topic, we can expect questions like, explain various data formats that can form ML elements. Machine learning elements include features, labels, and metadata, and these can be stored in formats like CSV, TSV, images, audio files, or even binary formats. Understanding the format helps in proper data handling, transformation, and feeding into the machine learning pipeline. Now let's move on to our next important topic, learnability in machine learning. From this topic, we can expect questions like, what is learnability in machine learning? Discuss its significance in model evaluation. Learnability refers to whether a machine learning model can learn a function accurately from the given data within reasonable time and resources. It is important because a model must generalize well and not just memorize training data. Evaluating learnability helps us ensure the model will perform well on new, unseen data. Now let's move on to our next important topic, statistical learning approaches. From this topic, we can expect questions like, what are various statistical learning approaches? Statistical learning includes methods like regression, classification, clustering, and dimensionality reduction. These approaches use mathematical statistics to analyze and predict outcomes based on data. They help in modeling uncertainty and drawing reliable conclusions from noisy data. Now let's move on to our next important topic, statistical learning approaches description. From this topic, we can expect questions like, describe various statistical learning approaches. Statistical learning approaches include linear regression, which predicts a numeric value, logistic regression, which is used for classification, support vector machines, which find boundaries between classes, and principal component analysis, which reduces the number of features in a dataset. Each of these methods uses mathematical and statistical techniques to extract meaningful patterns and make accurate predictions. Hello students! Welcome to another supercharged revision session for your in-semester exams. We are diving deep into Unit 2 Feature Engineering. This unit is extremely important because whatever machine learning model you choose, the performance of that model depends heavily on how well you handle the features. So let's break this unit down into simple concepts that even a 10-year-old can understand. And let's make sure you're completely exam ready. Let's begin with our first question. What is a feature in machine learning? Why is feature representation important? A feature is a measurable property or characteristic of a data sample. In simple words, it is the input we give to our machine learning model. For example, if we are predicting house prices, features can be the number of rooms, size of the house, or location. Feature representation is important because the model learns patterns from features. If the features are not represented properly, the model will not learn the right patterns and will give poor results. The better we represent the features, the more accurate the predictions will be. Now let's move on to our next important topic, normalization of data set. From this topic, we can expect questions like, convert given data set in normalized data set. D equals 23, 29, 52, 31, 45, 19, 18, 27. Normalization is the process of adjusting the values of numeric features to a common scale. We can use methods like min-max normalization, where we scale the values between 0 and 1, or Z-score normalization, which transforms the data to have a mean of 0 and standard deviation of 1. This helps machine learning models to understand all features equally, preventing one feature from dominating others just because of its large scale. Now let's move on to our next important topic, feature scaling of a vector. From this topic, we can expect questions like, consider a vector x equals 23, 29, 52, 31, 45, 19, 18, 27. Apply feature scaling and find out min-max scaled values as well as Z-score values. In this case, we calculate the minimum and maximum values of the vector. Then, using min-max formula, we subtract the minimum from each value and divide by the range. For Z-score, we find the mean and standard deviation, and for each value, we subtract the mean and divide by standard deviation. This gives us a standardized vector, which is very helpful for models that rely on distance measures, like k-nearest neighbor. Now let's move on to our next important topic, Z-score normalization for age attribute. From this topic, we can expect questions like, given following data for attribute age, calculate Z-score normalization. Age equals 18, 22, 25, 42, 28, 43, 33, 35, 56, 28. Here again, we apply the Z-score normalization formula, which is each value minus the mean divided by the standard deviation. This method is especially useful when the data contains outliers, because it centers the data and helps in removing skewness. Now let's move on to our next important topic, min-max normalization of a data set. From this topic, we can expect questions like, convert the following dataset into a normalized dataset using min-max normalization. Data D equals 12, 18, 30, 24, 15, 36, 27. To do this, we first identify the minimum, which is 12, and the maximum, which is 36. We then apply the formula, value minus minimum divided by maximum minus minimum. This brings every value into a range between 0 and 1. Normalized data helps algorithms converge faster and perform better. Now let's move on to our next important topic, min-max and Z-score scaling of a vector. From this topic, we can expect questions like, given the vector x equals 10, 20, 15, 25, 30, 18, 12. Perform both min-max scaling and Z-score normalization. This is another standard problem where you must apply both methods. Min-max scales everything between 0 and 1, and Z-score centers the data around 0. Make sure you calculate mean and standard deviation properly, and apply formulas step by step. Now let's move on to our next important topic, Z-score normalization for salary attribute. From this topic, we can expect questions like, for the attribute salary equals 30,000, 45,000, 50,000, 55,000, 60,000, 48,000, 52,000, calculate the Z-score normalized values. Once again, compute the mean salary and standard deviation. Then subtract the mean from each value and divide by the standard deviation. This converts all values to a standard scale. Z-score helps in highlighting how far a particular salary is from the average salary. Now let's move on to our next important topic, min-max normalization to range 0 to 1. From this topic, we can expect questions like, normalize the data set using min-max normalization to a range 0 to 1. Set equals 50, 55, 65, 80, 60, 45, 75. Apply the SEM min-max formula here. These scaled values are now between 0 and 1. This helps in removing the effective scale and makes models like gradient descent more stable. Now let's move on to our next important topic, Z-score normalization and outlier interpretation. From this topic, we can expect questions like, the following attribute represents ages of students in a class age equals 17, 19, 18, 20, 21, 19, 22, 23. Apply z-score normalization and interpret which value lies furthest from the mean. After z-score normalization, the value with the highest absolute z-score is the one that lies farthest from the mean. That value can be considered an outlier or exceptional case. Interpretation helps us understand data distribution and clean unnecessary outliers if needed. Now let's move on to our next important topic, handling missing values. From this topic, we can expect questions like, how to handle missing values in a dataset that will be used for training the machine learning model? Handling missing values is critical because most machine learning algorithms cannot handle them on their own. We can either remove the rows with missing values, or we can fill them using methods like mean, median, or mode imputation. For categorical data, we can use the most frequent value. We can also use advanced methods like predictive modeling to guess missing values. Now let's move on to our next important topic, use of PCA in preprocessing. From this topic, we can expect questions like, elaborate use of PCA in preprocessing stage. Principal component analysis helps in reducing the number of features while keeping the important information. It transforms the data into a set of linearly uncorrelated variables called principal components. This helps in reducing noise, improving model performance, and avoiding overfitting. Now let's move on to our next important topic, process of PCA. From this topic, we can expect questions like, explain the process of principal component analysis in brief. The process starts with standardizing the data, then finding the covariance matrix to understand how features vary with each other. Then we calculate the eigenvalues and eigenvectors of the matrix, which give us the principal components. We choose the top components based on variance and project the data into this new space. Now let's move on to our next important topic, kernel PCA. From this topic, we can expect questions like, explain kernel PCA in detail. Kernel PCA is an extension of principal component analysis that allows us to handle nonlinear data. It uses kernel functions like polynomial or radial basis function to map data into higher dimensions where linear separation is possible. It is very useful for pattern recognition, image processing, and text analysis. Now let's move on to our next important topic, LBP code calculation. From this topic, we can expect questions like, calculate LBP code generated value for the central point in the neighborhood of 8 pixels as shown below. The LBP or local binary pattern code is generated by comparing the central pixel with its 8 neighbors. If the neighbor pixel value is greater than or equal to the center, we write 1. Otherwise, we write 0. This gives us an 8-bit binary number that represents texture. The binary number is then converted into a decimal value. Now let's move on to our next important topic, LBP feature extraction technique. From this topic, we can expect questions like, explain local binary pattern feature extraction technique with suitable example. Local binary pattern is a texture descriptor. It captures local texture by comparing each pixel with its neighbors. For example, in face recognition, LBP features are used to identify texture patterns like wrinkles or skin smoothness. It is efficient, simple, and works well in real-time applications. Now let's move on to our next important topic, feature selection and filtering technique. From this topic, we can expect questions like, what is feature selection? Explain filtering technique. Feature selection is the process of selecting only the most relevant features for model building. Filtering technique does this by checking statistical relationships like correlation or chi-square score between the feature and output label. It is done before model training and helps improve model accuracy and reduce computation time. Now let's move on to our next important topic, sequential forward selection. From this topic, we can expect questions like, explain sequential forward selection method for feature selection with an example. In this method, we start with no features. Then we keep adding one feature at a time, which improves the model the most. We repeat this until adding more features does not improve performance. For example, in a dataset with 10 features, we may find that only 3 are needed to achieve good accuracy. Now let's move on to our next important topic, sequential backward selection. From this topic, we can expect questions like, explain sequential backward selection method for feature selection with an example. This is the opposite of forward selection. Here we start with all features and remove one by one, removing the least important feature each time. We continue until removing any more decreases accuracy. This method is useful when we know that most features are relevant but want to remove only unnecessary ones. Now let's move on to our next important topic, wrapper methods. From this topic, we can expect questions like, explain the types of wrapper methods for feature selection. Wrapper methods use the model's performance as feedback to select features. The common types include forward selection, backward elimination, and recursive feature elimination. These methods are more accurate but take more time, as they involve running the model multiple times. Now let's move on to our next important topic, statistical methods to describe data. From this topic, we can expect questions like, which statistical methods are used to describe the nature of data? Common statistical methods include mean, median, mode, variance, standard deviation, skewness, and kurtosis. These measures help us understand the central tendency, spread, and shape of the data distribution. They are useful in detecting outliers and understanding data quality. Now let's move on to our next important topic, features of multidimensional scaling. From this topic, we can expect questions like, what are the features of multidimensional scaling? Multidimensional scaling is a technique used to visualize the similarity or dissimilarity of data points in low-dimensional space. It helps in reducing dimensionality while preserving the distances between points. It is useful for exploratory data analysis and clustering tasks. Now let's move on to our next important topic, matrix factorization and content-based filtering. From this topic, we can expect questions like, what is matrix factorization? Explain content-based filtering with an example. Matrix factorization is a method used in recommendation systems to discover hidden patterns in user-item interactions. It breaks a large matrix into smaller ones to find relationships. Content-based filtering recommends items based on the features of the items and the preferences of the user. For example, if a user likes action movies, the system recommends other action movies based on item features.